If we're going to talk about our solar system, we got to talk about Pluto. Because everybody's got to ask, why isn't Pluto a planet anymore? What happened with Pluto? Why did it get kicked out of the Planets Club? Why does it have to sit at the little planets table at Thanksgiving? What's this? Why are astronomers being mean to Pluto? Why are they doing it? You know, why isn't it a planet? Why not? It was considered a planet for many years. What's the deal here? I mean, I guess at one level, I mean, it's words. Pluto doesn't care whether we call it a planet or not. You know, whether we stick the label planet on it or not. Who really cares one way or another? Pluto is the same thing it always was. It was out there long before we discovered it. It was out there. It's not like it's worried about it. So it's like, does this matter? And I argue that yes, it does. I think that our understanding of our solar system has changed in the last few years, and therefore our understanding of what Pluto is really, truly has changed. Okay, so let's review. Pluto was, you know, the last discovered of the 9 planets. You know, so we had Mercury, Venus, Earth, Mars, the terrestrial planets, near the Sun, made of rocks and metals, etc., etc. We got the Jovian planets. Jupiter, Saturn, Uranus, Neptune. They're big, they're absolutely enormous, they're far from the Sun, they're out in the colder part of the solar system, big orbits, you know, lots of gases, hydrogen, helium, liquids, solids, all this sort of thing like this. And then you got Pluto. Pluto's the last discovered in 1929, 1930, Pluto, and from the beginning, even then, it was kind of the last and the least of the planets. It was some people thought that, okay, there was something going on with the orbit of Neptune, something pulling on it, and so they were looking for another planet, and they found Pluto, and aha, that's it. Well, no, it wasn't Pluto. Pluto was way too small to have any effect on the orbit of Neptune, but they did find it. It is out there. It's a real object, but it's made of a mixture of rock, metal, and ices, and it's way smaller than the Jovians, and way smaller than the terrestrials. It's the smallest. It's smaller than Mercury, the smallest of the terrestrials. So it's smaller than Mercury. It's made of different stuff and is a total region of the solar system. So for 50 years, Pluto is the last and the least of the planets. Pluto is the ugly duckling of the solar system. It's this strange object. It's not a terrestrial planet. It's not a Jovian planet. It's just this one oddball. It's this unique, one-off, bizarre object, unlike anything else in the whole solar system. And so then that's why it was included in as a planet. Well, you know, it's all alone out there. It's lonely. It's all by itself. Let's be nice to it. Let's let it in the Planets Club. It was the last and the least of the planets. It's the ugly duckling. It's this one unique oddball. And then what was discovered in the 1990s is that understanding of Pluto. Pluto as a unique oddball was completely wrong. We were completely and totally wrong in thinking that Pluto was one unique, odd object, because it's not. Pluto, instead, is part of a collection of objects. Pluto is part of the, what's being called the Kuiper Belt, K-U-I-P-E-R, the Kuiper Belt, named after the American astronomer Gerard Kuiper, who back in the 1950s postulated, he suggested the idea that out there beyond Neptune there should be a lot of these ice ball sorts of things floating on. He figured that gravity wouldn't be enough to gather them all together into another big Uranus-Neptune-sized planet, but there still would be a substantial amount of material out there, so he figured there would be this belt of icy objects out there, and turns out he was right, and that Pluto is one of them, and there are billions of others. Billions of others. Pluto is one of the largest. There's at least one larger than Pluto, but most of them are smaller. Mostly smaller. But there are lots of Plutos out there. Pluto isn't one strange, oddball, unique, unusual object. No, Pluto's part of a collection. There are billions of other Plutos out there. And if we're going to let Pluto be a planet, well, what about all these billions of others? Should we then ask all the elementary school kids to learn the name of all those billions of planets? I don't think so. That would be cruel. And let's also emphasize that this has happened before. This is not the first time that we've had to reorganize our solar system. This happened in the 1800s as well. So back, okay, the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, were all known since ancient times. All ancient peoples knew about those planets. And then Uranus was discovered by the astronomer William Herschel. It's the first time in history that someone discovered a planet. Before that, they'd just always been known since ancient times. And then, Neptune discovered as well. Well, after the planet Uranus was discovered, another planet was discovered. And the planet, and there were actually a bunch of planets discovered. So let's do a little history here. History. In the 1800s, many planets were discovered. In the early 1800s, the planet Ceres was discovered. After that, the planet Vesta was discovered. The planet Juno was discovered. The planet Pallas was discovered. And then by kind of the late 1800s, now all of these turned out to be kind of smallish sort of objects. And then as we built better and better telescopes to find more and more of them, we found that there were more and more, so that we could find smaller and smaller. We found lots of them, and we found that all these objects orbit between Mars and Jupiter. And then with better telescope, we found that there were thousands, millions of these objects. Just depends on how small you want to go down. You have lots and lots of these planets out there. And so in the late 1800s, astronomers it wasn't quite as official as with Pluto, but drew the conclusion that, hey, Ceres and Vesta and Juno and Pallas and these things are all these small mountain-sized, continent-sized, and smaller objects out there orbiting between Mars and Jupiter. And hey, there's thousands and thousands of them. As you get better and better telescopes, you discover more and more. They're a collection of objects. Let's group them together and call them the asteroid belt. So, Ceres, Vesta, Juno, and Pallas were no longer considered planets. They were called asteroids. And I think that was a good thing. It helps us understand something, that there's this collection of many, many objects out there, some large and then getting smaller and smaller and smaller, lots of small ones out there between Mars and Jupiter. And this is what's happened again. First, we knew about Pluto, and we thought Pluto was unique and alone. It is neither. It is not unique, and it's not alone. There are billions of other Plutos out there, most of them smaller and smaller and smaller than Pluto. And they're out there in this region that, okay, let's group them together and call them the Kuiper Belt. That makes sense. So we have 4 terrestrial planets, we have 4 Jovian planets, we have the asteroids, and then we have the Kuiper Belt as well. And then there's some material scattered beyond the Kuiper Belt, and that's really interesting. So let's talk about what that is. So Pluto is one of the largest. Pluto isn't the ugly duckling of the planets. No, it's not an ugly duckling at all. It's a beautiful Kuiper Belt object. It's a swan sort of thing. So the story has a happy ending. So let's think about this. So we're talking about small objects. Small objects, of which Pluto fits in there. First of all, we have the asteroids. And then we have these Kuiper Belt objects. Asteroids are usually have a lot of rock and metal in them. They're forming out here kind of around the frost line. There may be substantial amounts of ice in many asteroids as well. As we measure them more and more, it's like, oh, there's a fair bit of ice in there. On the surface, it's all cooked off by the sun over the 4.5 billion years since our solar system formed. But deep within that's hidden from the sun. Okay, so you can have a stanch of rock, metal, and ices too. To varying different degrees. And then you've got these Kuiper Belt objects. Since they're in the outer solar system, they are also rock, metal, but have more ices than the asteroids. Well, ices than the asteroids do. And this also helps kind of connect up and explain comets. What's a comet? Well, a comet is, okay, let's not confuse here a meteor and a comet. A meteor is when you're out at night and you see a whoosh, little streak across the sky. That's a meteor. It's caused by a piece of dust or a piece of, something of the object of the size of a grain of sand, maybe a pebble, falling into the Earth's atmosphere and burning up. And so that's what a meteor is. It's brief, it lasts for a second. If it's big enough, a chunk of it, maybe something the size of your fist, might fall to the Earth. A comet, on the other hand, appears in the sky, and you'll see it over many, many weeks and maybe even months. Certainly days, and the nice big ones, Halley's Comet, Comet Yakutaki, Comet Hale-Bopp, can be visible with the naked eye. You've got a big round part in the center, which is called the coma, and then you got a tail which streams out. So there's the coma, which surrounds the nucleus, and then we've got the tail. The tail points away from the sun. So even if the comet's moving away from the sun, then the tail points out in front of it. The tail is not streaming behind the comet. No, the tail is gas pushed away by the sun. So if the comet's moving away from the sun, well, then that tail sort of thing leads the way, so that people get confused with that. So what is a comet made of? Comet is basically a dirty snowball. Dirty snowball. And we see these comets. They appear, some of them you see regularly, like Halley's Comet, every 76 years. Others come in and that appears to be about it for them. But they've been observed since ancient times. They were thought to be harbingers of doom and all this sort of thing. Well, now we know they're just these big dirty snowballs orbiting around the sun, and they have these very elliptical orbits. So they'll come in close to the sun. Once they cross inside the orbit of Mars, cross inside the frost line, they start to melt, and then they give off all this gas, and then they're big, beautiful things we can see in the sky. They come around the sun, and then they go out away. And once they get beyond the orbit of Mars, now then they start to cool off and freeze again. And people started looking at the orbits of these and found that, hey, there's many of these that orbit around with a period of about, say, 200 years or something like that. And those all seem to orbit in the flat disk of the solar system. And then some of them, on the other hand, oh, you know, you do the calculation, oh, this is going to come around the sun once every 1,000 years. You know, they have these absolutely enormous orbital periods. And they seem to come from almost any direction at all. They can go in any direction. So these long period of comets, many hundreds, many thousands of years, these come from any direction. But the comets which are 100, 200 years, something like that, 70 years, like Halley's Comet, they seem to be a more flat distribution. So even long ago, people postulated, oh, these comets must come from some outer area of the solar system where you got these dirty snowballs floating around out there, and near the closer in area would be relatively flat, like a belt, and then beyond that you would have a cloud. And so the comets are coming from the Kuiper Belt. Now we're actually seeing these Kuiper Belt objects out there, you know, these Pluto-like objects out there in situ, where they live, out in the outer solar system beyond the orbit of Neptune. Now we can see, we've discovered many of these Kuiper Belt objects. And so that confirms what we were getting just from watching the comets coming in. And it's also thought that the other source of comets, so we got comets, the short period comets, you know, 100 years, like what's 100 years between friends? So comets, so we have the short period, which come from the Kuiper Belt, Kuiper Belt, and then the long period comets, well, since they come from any direction, many thousands of years, we've hypothesized that there is a region of those out there called the Oort cloud, postulated by Jan van Oort, and we have not, our telescopes cannot see that, you know, they can't see them out there at that distance from the sun, but that would be very far from the sun, much farther beyond Pluto. But the short period comets, we've now found where they live out there in the Kuiper Belt, and so that helps us to understand things. And if something were to hit Pluto or tweak its orbit and Pluto were to fall into the inner solar system, Pluto would be a comet, an enormous comet, but it would develop a coma, it would develop a tail. Pluto is part of this Kuiper Belt out there. It totally makes sense. It would be one of these things which would be a short period comet. If something hit it, you know, if it bounced into something, crashed into something, and then got knocked into the inner solar system. So that helps us understand Pluto within the context of these small objects in our solar system.